So this is a presentation about Leviatys, an innovative method for the calibration of high-capacity weighing instrument in industry. Let's say a few words about Cerib, which is the Industrial Technical Center for Precast Concrete, based in Épernay. We have activities in laboratories and on-site, and studies and research, standardization, testing, and we shall speak more about metrology in mechanical quantities. So what picture do we have in mind about weighing activities? According to common sense, we first have in mind this picture, which means very small quantities. But in industry, a better picture about weighing activities is this one, because we have scales up to several tons. So as we can see, in many fields of industry, chemistry, food industry, concrete industry, non-automatic weighing instruments are used to determine a quantity of raw material poured before manufacturing. And how are the calibrations of these instruments carried out? Let's say that we will need 20 kilogram cast iron masses, so at least 500 kilograms or 1 ton, a special vehicle to carry masses on site, and people to carry masses up to the load receptor. And I must say that very often we can see people running away when they see our truck arriving for the calibration. So what are the difficulties with standard masses? The difficulties are due to high capacity instruments with hardship, immobilization of production, access difficulties, and use of substitution loads. So let's see now the Leviatys measurement principle. We had to find out another method for the calibration of weighing instruments, and Leviatys is a calibration process used for the calibration of non-automatic weighing instruments without standard mass. It uses the counter-thrust principle. So as we can see on the picture, the blue arrow shows the movement of the load receptor, and the yellow arrow shows the work of the Leviatys process as a counter-thrust system. Now the procedure of calibration with Leviatys. Step 1, loading the scale to its maximum with the usual weighed product, Vmax. So the usual raw material is used. It can be concrete aggregates, cocoa beans, or whatever. Second step, installation of the jacks under the load receptor frame. The jacks will be able to relieve the load receptor when they move up, as we can see on the picture. And step 3, measurement. So the jacks move upward and lift the load receptor of X kilogram. So we'll have to compare reading on the weighing instrument, R1, and reading on the force sensor, R2, which is a cumulation of 3 measurements of the force sensors. This is the way to determine the error of indication. Now we had to put the idea into practice. At first we had to do a laboratory test. So as we can see on this photograph, we had to perform different tests of mobility, repeatability, extrinsicy, and determination of accuracy. Then design of mechanical means. So the jacks are specially designed for robustness, small 8 because it is less than 20 centimeters, and weight around 20 kilograms. On the right of this picture, we can see the 3 measuring devices for Leviatys process. And then assessment of influencing factors. So the picture shows a tilt test experiment with comparison of readings with different angles. So we can see up the simulated load receptor with standard masses, so we can know the mass applied. And under the load receptor, 3 jacks for the Leviatys system. Now testing the reliability of the method. So we had to perform on-site measurements and comparisons in order to check the reliability of this method. We can see on the right here the weighing belt after installation of the jacks. On this other picture, we can see the load receptor pre-charging phase up to 3 tons. And with the arrows, we can see aggregates poured on the load receptor. And this is the measuring phase with acquisition of measurements on 3 positions before cumulative calculation of the value. We can see here the counter thrust action of the jacks. Now let's say a few words about uncertainty of measurement. So we had to determine the components of uncertainty due to force standard. So we had to determine components due to calibration, resolution, repeatability, reproducibility, drift between 2 calibrations, and so on. Components due to environment, temperature effects on the sensors. So we go up to 15 degrees, around 20 degrees, because we are really in on one-site conditions, tilt effect, and on-site gravity acceleration, and weighing instrument contribution, so at least resolution and repeatability. The results of this uncertainty measurement, we estimated the uncertainty of measurement around 0.5% of the applied mass, so which is more than the uncertainty of measurement with standard masses, but quite enough for industrial applications we can find in many fields of industry. We can see 3 main factors. So the main factor was temperature effects on the force measurement, mechanical effects, and also tilt effects. So what are the advantages of Leviatys and improvement tracks? So of course the advantages are safety and ergonomics, remote control of the jacks, and it is really specially designed for heavy loads up to 6 tons. Of course we have to work on improvements like wireless measurement, choice of sensor for effect of temperature, and improvement of jacks control box. Let's say a few words as a conclusion. So the metrological verification of weighing instruments is a major issue for many manufacturing sites because of raw materials and regularity of product completion. Leviatys provides a practical solutions in case of high-scale measurement. So, with a reasonable measurement uncertainty, we saw around 0.5% of the mass, requiring less personnel than the method with standard masses, one metrologist, and reducing production interruption due to calibration, around 1 hour. This process is still called to evolve, to be adapted to special cases of installation and to further improve in its ergonomics for operators. Leviatys, we can say, is a patented and accredited calibration method. And let's hope it will help making weighing metrology more popular in industry. Thank you for your attention.